Instead of having individual registers performing the micro-operations directly, computer systems employ a number of storage registers connected to a common operational unit called an arithmetic logic unit, which is abbreviated as ALU. To perform a micro-operation, the contents of specified registers are placed in the inputs of the common ALU. The ALU performs an operation and the result of the operation is then transferred to a destination register. The ALU performs an operation and the result of the operation is then transferred to a destination register. The ALU is a combinational circuit so that the entire register transfer operation from the source registers through the ALU and into the destination register can be performed during one clock pulse period. The shift micro-operations are often performed in a separate unit, but sometimes the shift unit is made part of the overall ALU. The arithmetic, logic and shift circuits introduced in previous sections can be combined into one ALU with common selection variables. One stage of an arithmetic logic shift unit can be seen here. The subscript I designates a typical stage. Inputs AI and BI are applied to both the arithmetic and logic units. A particular micro-operation is selected with inputs S1 and S0. A 4x1 multiplexer at the output chooses between an arithmetic output in EI and a logic output in HI. The data in the multiplexer are selected with inputs S3 and S2. The other two data inputs to the multiplexer receive inputs AI-1 for the shift right operation and AI+1 for the shift left operation. We note that the diagram shows just one typical stage. The circuit of figure must be repeated n times for an n-bit ALU. The output carry Ci+1 of a given arithmetic stage must be connected to the input carry Ci of the next stage in sequence. The input carry to the first stage is the input carry Cn, which provides a selection variable for the arithmetic operations. The circuit whose one stage is specified provides 8 arithmetic operations, 4 logic operations and 2 shift operations. Each operation is selected with the 5 variables S3, S2, S1, S0 and Cin. The input carry Cn is used for selecting an arithmetic operation only. The table lists the 14 operations of the ALU. The first 8 are arithmetic operations and are selected with S3, S2 equal to 0, 0. The next 4 are logic operations and are selected with S3, S2 equals to 0, 1. The input carry has no effect during the logic operations and is marked with don't care X's. The last two operations are shift operations and are selected with S3, S2 equals to 1, 0 and 1, 1. The other three selection inputs have no effect on the shift.